In today's session, we will see the binary arithmetic, mainly the addition and subtraction. So in binary addition, a circuit that performs 2-bit addition is known as half adder, and a circuit that performs 3-bit addition is known as full adder, that we'll discuss later. Now this is the truth table for half adder. Two input bits we are considering A and B, and the outputs are sum and carry. So since there are two input bits, 4 combinations are possible: 0, 0, 0, 1, 1, 0, 1, 1. Now we will see the addition here. First addition 0 plus 0. Then sum 0, carry 0. 0 plus 1, sum 1, carry 0. 1 plus 0, sum 1, carry 0. 1 plus 1. So 1 plus 1 in decimal it is 2. But what is the binary equivalent of 2? Binary equivalent of 2 is 1, 0. So here when we are doing 1 plus 1, the answer is 1, 0. But we will write the sum as 0 and the carry as 1. Why we are writing the sum as 0 and carry as 1? For example, in decimal addition, if you want to add 43 and 8, 43 plus 8, how we will do the addition? First, we will do the addition to the LS base, that means 3 plus 8. What is 3 plus 8? 11. But we won't write 11 here. What will write here? We will write 1 here, and 1 will be considered as the carry. So same way here also, 1 plus 1 answer is 1, 0. That means the sum is 0 and this 1 will be considered as the carry here. So this is the truth table of what? Half adder. Now we will see an example for addition of two binary data, 1 1 0 0 1 0 1 0 1 plus 0 1 1 0 1 1 0. So same like in decimal addition, we'll start from the LSBs here. 1 plus 0 1, 0 plus 1 1, 1 plus 1 0, carry 1, and this carry 1 plus 0 1, that 1 plus 0 1. Now again 1 plus 1 0, carry 1, and that 1 plus 0 1, that 1 plus 1 0, carry 1, 1 plus 0 1, 1 plus 0 1, then 1 1, and this is the sum. Now we will see the binary subtraction. Here also, if a circuit performs 2-bit subtraction, that is known as half subtractor, and a circuit that performs 3-bit subtraction is known as full subtractor. Now this is the truth table for half subtractor. Two input bits we are considering A and B, and there are two outputs for the subtractor, difference and borrow. Now since we are considering two input bits, 4 combinations are possible: 0 0, 0 1, 1 0, 1 1. Now 0 minus 0, difference 0, borrow 0. 0 minus 1, we cannot subtract 1 directly from 0. We have to borrow 1. So since we are borrowing, this borrow is getting 1. Okay. Now because we are borrowing 1, the 0 is going to be 1 0. After borrowing 1, the 0 is becoming 1 0. Now 1 0 minus 1. 1 0 is equivalent to 2 in decimal. So 2 minus 1. What is 2 minus 1? 1. So the difference is 1. So 0 minus 1 is difference 1, borrow 1. Now 1 minus 0. What is 1 minus 0? Difference 1, borrow 0. 1 minus 1. Difference 0, borrow 0. More clarity, I will tell you the 0 minus 1 again. 0 minus 1. We cannot subtract 1 from 0 directly. So we have to borrow 1. If you are borrowing 1, the 0 is going to be 1 0. We'll see in decimal subtraction. For example, if you want to subtract 8 from 43, how we do that? First we have to subtract 8 from 3. But we cannot subtract 8 from 3. In that case, we have to borrow 1. If you are borrowing 1, this 3 is going to be 1 3 or 13. Then we will do what? 13 minus 8. Then we'll write 5. Answer here. So same way here also. If you are borrowing 1, the 0 is going to be 1 0. Then we have to perform what? 1 0 minus 1. Then what is 1 0? Equivalent to 2. And this is 1. So 2 minus 1, the answer is 1. So that is how we are getting for 0 minus 1, borrow is 1 and the difference is 1.